Welcome. In this video we're going to talk about complements and the complement rule in probability. So as a reminder, S is the symbol we use for a sample space, and so this is the collection of all the possible outcomes for a probability experiment. Sometimes we'll use a lowercase e with subscripts to represent all the elements that are in that collection. So I'm going to just kind of list some things here. So this sample space has the outcomes E1 through En. And so let's say that we define an event, and we'll just call it E. And so this has some of these outcomes, maybe E1, E2, and E3. And so I want to introduce the notion of a complement. So depending on where you look, there are different notations that we use for complement. Some places will use a superscript of C, like this. Other places you might see just an apostrophe. Elsewhere I've seen like just a bar over the symbol, or just the word not, and then with a set of parentheses, and whichever event you want to indicate just inside the parentheses. So whichever notation you use, and I favor the first one here. This means, I'm just going to EC, that's the complement of E, is the collection of all elements, so, in other words, outcomes, in S. That's the sample space, not in E. And it's this not here that certainly explains why some people use this notation. So if my event E was defined as E1, 2, and 3, then in this case E's complement would be the set of E4 through E to the N. If this was my sample space. So let's give an example where maybe the probability experiment is to roll a fair die. And so our sample space would be the outcomes 1, 2, 3, 4, 5, and 6. And so let's create an event E, and that will be the outcomes, let's say 2, 4, and 6. The even numbers. So in this case, E's complement would be the collection of items that I didn't include in E. So in other words, the odd numbers, 1, 3, and 5. So how do we find the probability associated with a complement? So the rule here is if I take 1 minus the probability of E, I'll have the probability of E's complement. So either E is going to happen or not. So this is the probability that it does happen, and this is the probability that it doesn't happen. Now certainly when you add those two together, there's a 100% chance of that happening. It's going to happen or it's not going to happen. Those are the only two possibilities, so when you add those up we get 100. So in this, the way that I've written here, I've just subtracted this term to the other side to get 1 minus the probability of E. Of course, you could also write this in terms of probability of E, and that would be 1 minus the probability of E's complement, 1 minus the probability that it doesn't happen. For many people, this is intuitive. For instance, if I told you that there was a 20% chance of rain, I think most people would understand that that indicates that there's an 80% chance that it won't rain, because either it will or it won't. Now in this case there were just two possibilities, it will or it won't. But sometimes your event has more than one outcome in it, so such as in this example where there were 3 things in the event E and another 3 things in E's complement. The complement rule can come in really handy if you have a list of possibilities. Let's say that we still have a 6 possible outcomes. So these are my outcomes, and then over here I'll have the probabilities. And let's say that the probability for 1, so this is not a fair die, this is something else, and maybe this has a probability of 0.10, and maybe this has 0.378, and this is 0.221, and so forth. So, I know that all of these are going to add up to 1. This is a valid probability model. And so let's just say in this case I wanted to know the, let me give myself a little bit more room here. So again, I'm using this probability model here. And I'm interested in the probability that I would get at least a 2 as an outcome. Alright, so one option here would be that I could add up the probability of a 2 plus the probability of a 3 plus the probability of a 4 plus the probability of a 5 plus the probability of a 6. So that's one option. But another thing to realize is that this event, which consists of these outcomes, is the complement of 1. So the probability of at least 2 is, the probability of at least 2 is 1 minus the probability that I would get a 1. Well, I know that that has a probability of 0.10, so I can just say 1 minus 0.1, which is 0.9. So there's a 90% chance that I would get at least a 2. So oftentimes it's easier to subtract a probability from 1 rather than to add up probabilities using the addition rule. Alright, so that's a brief explanation of complements and the complement rule.